Hello there, science class. I wanted to talk to you for just a few minutes about atoms and molecules. It's section 7.1 on page 136 in your book. We've talked about atoms and how that the atoms are the smallest piece of matter that can still be an element. You can have subatomic particles like a proton or electron or a neutron, but they're not an element. You have to have atoms in order to have an element. So an atom is the smallest thing that is still an element. There's only about 90 elements that are found naturally in the environment. If you go out, dig around in the dirt, you're going to find it. At the same time, there are millions of chemicals out there. All of those roughly 80 or 90 elements combine to make millions of chemicals. As a matter of fact, just carbon alone can combine with other elements to make almost 10 million chemicals. So we're going to start first with talking about a molecule. We know that an atom is just one single thing. It's the smallest you can get. But a lot of times, even in nature, atoms don't exist alone by themselves, just one atom. For instance, oxygen. In nature, it's not just the atom, oxygen, it's O2, which means it's an O, which is the symbol for oxygen, and a 2, a subscript 2 in the lower part, which means that there are two atoms of oxygen. And those two atoms of oxygen are hooked together, and it's called O2. Oxygen with two atoms. Same thing with hydrogen. Hydrogen is usually found as H2. And those atoms are hooked together. It all has to do with sharing electrons. It has to do with the octet rule and wanting to have 8 valence electrons. When you have 2 or more atoms that join together, it's called a molecule. So if you have O2, oxygen with a 2 down there, that tells you that there's 2 atoms, and those 2 atoms are joined together, and those 2 atoms are called a molecule. So we would speak of it as a molecule of O2, or in the case of hydrogen, a molecule of H2. The way we read about finding what the nuclear mass was of an atom, and it shows us right on the periodic table. You know, you look at any of those elements there in the periodic table, for instance, magnesium, which is atomic number 12. Magnesium has an atomic mass, which is the average atomic mass, of 24.31. That means that the protons in the mass and the neutrons in the mass on average add up to 24.31. That means that there's 12 protons and there are 12 neutrons, and every now and then you'll get a 13th neutron in an atom. But the way that you discover a molecular mass, the mass of a molecule, is you have to add the individual nuclear masses together of each element that's in the molecule. let's go back to our periodic table, which you'll find on page 131. And let's say that you have O2. You have oxygen. You have two atoms of oxygen hooked together. And we find oxygen is number 8 on the periodic table. It's in that second period there going across. And it says here that its average atomic mass is 16. 8 protons, 8 neutrons. That's for one atom. If you want to find the average molecular mass, the mass for a molecule, we know that it's O2. And so you have to take that average atomic mass for oxygen, which is 16. You have to multiply it by 2 because that's how many atoms you have, and that gives you a total of 32. So the average molecular mass is 32. That would be the average mass of the molecule. Same way you can do it with water. Water has 2 atoms of hydrogen and 1 of oxygen. We know that oxygen has an average molecular mass of 16. We know hydrogen has oxygen has an average nuclear mass of 16, and hydrogen has an average nuclear mass of 1.08. Well, if you're going to have H2, which is 2 hydrogen atoms, and oxygen, which is 1 oxygen atom, we know we have to take the average nuclear mass of the hydrogen, which is 1.008. We're going to have 2 of them, so we add those together. That makes 1.016. And then we have to add it to the average nuclear weight of oxygen, which is 16. So we add 16 plus 2.016, and that means we're going to have 18.016. And if you round that up, that's 18.02, give or take, around that. We have an application at the bottom of page 36 having to do with that, where it says, determine the molecular mass of the following molecules. Use the average atomic masses from the periodic table on page 131. Well, that's what we've been doing. The first one is S8. Well, the S8, the atomic symbol S stands for sulfur. And we will find that in the periodic table in the third period, third row down, number 16. That's its atomic mass. Well, this is going to be S8. We've got 8 sulfur atoms, and we have an average atomic mass of 32.06. We multiply 32.06 times 8, and that'll give us the answer for sulfur, or S8, sulfur 8. Don't have my calculator with her. I'd do it for you, but I'm sure you have a calculator and you can pause this and do it. I want you all to do that application there, and I'll be back with you to finish up, or at least move ahead. Thanks, and I'll talk to you later.